and we will jump into things here. Having said, oops, I pressed the wrong thing. Give me a second to find my stuff. Here we go. Okay, we're in the right place. Um, so I'm going to give you guys a minute to go ahead and copy down what you see on the screen. I'll just give you a minute. I'll pause my recording and let you copy this because I know there's quite a bit of information here. So, all right, there we are. So the two chapters we're covering this week in TS 76 are chapter 10, basically, on scatter plots. And then chapter 11 is about conversions of inches to feet or miles or millimeters to meters or grams to kilograms. Anyway, so last week I'm just going to take a moment and review a little bit. I talked to you guys about charts and graphs, and I talked to you about this one right here. I talked to you guys about pie charts, and I told you that a pie chart is really nice for comparing if you wanted to compare the part with the whole. Like, let's say we had everything else, so we only had two different variables here. We could see how small that variable is compared to the whole pie here. And that was kind of the key concept is pie charts are really good when you want to compare a part compared to the whole pie, the whole thing, okay? And then we looked over bar graphs, and we talked about the bar graph is how it was named as a bar graph because it has bars on it, okay, that look like bars. And they're nice to compare a part to part. So for instance, on my little chart here that I'm my little bar graph, I can see which part is the smallest compared to all the other parts. The yellow is. And so they're really good at comparing a part to a part. Pies for a part are good at comparing the part, the little part here, I'll color it in yellow here, to the whole. And then we also talked about one more type of graph. We talked about what's called a line graph, and they're named that way because they often have lines on them. Okay, they kind of go up in a certain direction, or they can go down. Sometimes they might go down, but they have lines on them, and they're called line. And we said, what are they best for? They're best for showing a change. Okay, usually that, not always, but a change over time. That's because we talked about how on this x-axis, this one right here, and then there's the y-axis, okay? Very often the independent variable, which we're about to talk about tonight, is the x-axis, okay? So, having said that, yes, let me just look at this example I have. So the best for showing a relationship between two variables is a scatter plot, okay? So what is it best for? It's best for showing the relationship between two variables. Think about this as the x line and the y variable, okay? They show how they're related. I have a chart here, okay, and this is a scatter plot graph, or a scatter plot because it has dots on it. The little dots that are scattered can be scattered all over the place. They call it a scatter plot. And here's what I mean by they're best for showing the relationship between a variable. I went to a tour of Boeing a couple of years ago with some students, and we got to tour one of the largest building in the world at Boeing, and at the end of the presentation, a gentleman said, I need to talk to you, all the students, for 10 minutes, and called them all over, and he gave them he appealed to them, begged them practically to apply at Boeing. This is a few years ago, just a few years ago, before they messed up with their Dreamliner and lost a bunch of money. But they're starting to make recovery now. But he was begging these young people to apply at Boeing, and he was talking about. He said the first couple of years when you work at Boeing, even if you have no skill at all, we're just training you how to do how to do divots or rivets into something. The first 4 years of your your employment, your salary might just go up a little bit here. So let's say the first year you make 40,000. You notice the year is the X variable and the salary is the Y variable, 40,000. Second year, that's a big raise, by the way. So this is an exaggeration, but he pointed out that after 5 years, this is what he told these young people. After 5 years, you will jump up to 90,000 a year. This is back just a couple of years ago when you reach your 5 year mark. And so that variable, the variable of 5 years is a magic big number for him if you reach that five, because you have a big jump in pay. Okay. So again, scatter plots are best for showing the direct relationship, because what it is a direct relationship. We have the x-axis and the y-axis, and they meet at a specific point. And so you can see exactly at 5 years how much that you would be making 90 grand, and how much you'd be making in the other years, exactly between the x and the y. Okay, it's a direct correlation, a direct relationship between those two. Oh, I also want to point out a couple of other things. I want to re-emphasize this. We learned in this course a couple of weeks ago about the coordinate system, okay? And we learned that in the coordinate system, there's the x-axis down here, okay? All the numbers on the x-axis. And we also learned that it can be like this, where you have 0 and you have negative numbers and you have positive numbers, okay? But we learned that this line is the x and this line is the y up here, okay? Now, oftentimes in line graphs, in fact, almost every time you're going to see this. In fact, I don't think that I can think of an exception. The number on the x-axis is what's called the independent variable, okay, which we're going to talk more about in a moment. It's independent of anything else. It just is. You work 3 years or you work 5 years, you're just doing that. But what is that 5 years experience giving you? It's affecting the y, which is over here, the y-axis. It's affecting this variable is now called the dependent variable. Your salary is dependent upon what? How many years you work. And by the way, as a quick side note, that's a really kind of an important question to ask whenever you're going into a job or a field, a career, is to ask what's the beginning salary, what's a mid-career salary, and what's after you've been working there for 20 years or so, what's the salary? Because there are jobs that are what's called dead end jobs. They go up a little bit and then that's it. That's as far as you're going to go for the rest of your life. And then there are a number of jobs and a number of places where you can work where you can keep advancing in pay. And it's kind of, that's something you should consider when you're considering a job, if pay is going to be important to you. Okay. And so, but back into my X and Y. So the X axis, these numbers down here on this horizontal line are independent. They just are. Nothing's affecting them. You're just working that many years, but the amount of years you work, okay, affects the dependent variable, which is over here on the left, okay, the y-axis, okay. All right. I think what I'm going to do right now is I'm going to pause. I'm recording. Okay, I want to show you some examples here now, some variables, some kinds of questions, and we will have at least one of these on our next exam. So I wanted to show you this, okay? So let me make it bigger here. Okay, directions. Identify the independent and the dependent variables in the following statements, okay? So the more time people spend using social media, the less time they read books, okay? So if we were trying to figure out, okay, what is our independent and dependent variables? Could you guess which is which? Okay, which one's your dependent and which is our independent variable? All right, I'll just pick a red pen here. And let me just pick a little bit larger size and see what happens. There we go. So the independent variable, the more time people spend using social media, okay, this right here, this is they're just choosing to do this. Nothing's affecting this. Okay, so I could write down time using, I'm going to abbreviate SOC media, okay? This would be my independent variable. Now, what does it affect? Okay, the dependent variable is going to be the less they read. So this is time reading, okay? Okay, so that is my dependent variable. It is affected by, and if it was on a graph again, this would be the time, this would be my time of social media. And this one over here would be reading time, okay? So that's kind of the X and the Y. This is the X, this is the Y. All right, let's look at another example here. I can kind of scroll up here a little bit. Let's see, there's an eraser. Clear, does that do it? Clear all drawing. Yep, that did it. Drinking energy drinks makes people more aggressive. Can you think about it for a second? Which is the dependent and which is the independent variable? Okay, you think for a minute there. Okay, drinking energy drinks makes it, it causes something here. This word makes is almost like a hint. So this is my, you know, how much of this I drink, drinking, okay, energy drinks. All right, and it, what does it affect? How aggressive. So I can even just AGGRESSIVENESS. Okay, aggressiveness, how aggressive people get. That is the dependent variable. Look at the next example. Taking a nap in the afternoon makes people more focused the rest of the day. Okay, what's my independent variable? The nap in the afternoon. I'm going to say just nap at noon. That is my independent, okay? I'm just choosing to do that. What is it affecting? This nap is affecting my focus, okay? So that's my dependent variable is my focus. Come on, there he goes. All right, we're going to keep going here because I really wanted you to see a bunch of examples here of dependent. By the way, if someone reminds me to at the end of class, I will try to email this sheet right here that we're looking at, these examples. I can email it to you, and not only email it to you, but I'll email you the one that has the answers on it. Okay, so you'll see the examples with the examples. Okay. Let's just talk through these ones here, okay? Spending time with a family dog decreases the amount of stress someone is feeling. They've actually tested this, that our pets make us feel less stressed. They actually calm us down. So time with dog is my independent variable. And what does it affect? Stress level, okay? So dependent level is the stress level. That would be my dependent variable. All right, look at another example. Eating breakfast in the morning increases the ability to learn in school. Well, independent variable, breakfast in the morning. What does it affect? Amount of learning in school, or the learning in school, okay? Now, these ones are a little bit easier. Now we're going to go on to a little bit more challenging examples here. Okay, I'm going to show you some of these a little bit more challenging examples. Again, we're identifying which is the independent, which is we're just doing that action. It's not being affected by anything. We're just doing it, but it's affecting something else, okay? Students watched a cartoon either alone or with others. And then they rated how funny they found the cartoon to be. All right, if I said, can you think about that for a moment and choose which is the independent variable and which is the dependent variable? I'll let you think about that for a couple seconds. Okay, it would look like this, okay? Watching cartoons alone or with others, this is my I. I'll put an I by it. This is my independent variable, okay? How funny they found the TV shows, this is my dependent variable, okay? Because it's effective. They actually have done studies on this. And if you watch funnies, like a comedy, and you're in a room with other people, you tend to, and then they ask you afterwards, how funny would you rate that movie? People will rate the movie funnier if they saw it with other people. If you watch a funny movie all by yourself, it's not quite as funny. I guess shared humor, shared experience is important. Number two, a comprehension test was given to students after they had studied a textbook material, either in silence or with a television on. Okay, so they gave them a test after they'd studied either in silence or with a TV on. What is the independent variable? What is the thing they're doing first that's going to be affecting the other thing? Okay, here it is. Studying silent or with somebody in the with a TV. Okay, with TV. So that's my independent variable. Okay, what does it affect? It will affect the score on this test. That's my dependent variable. It's going to affect this. And again, this same worksheet I'm going over right now, if you're feeling like a little bit rushed, I need to study this more and I like to be able to see the answers, I will email this to you with the answers on it, okay? So you can kind of slow down if you need to and kind of absorb this a little bit more clearly. All right, let's just do one more, okay? If you don't mind me taking just one more here. Number three. All right, some elementary school teachers, they were told, and by the way, this might have been a study. It's sad if it was, but we'll give the example. Some elementary school teachers were told that a child's parents were college graduates. And other teachers were told that the child's parents had not finished high school. Then they rated the child's grades. Okay. This is a little bit complicated. So it's a school, and this Johnny, we'll call him Johnny, or Kathy. Kathy starts the school. Say Kathy starts at the school. And they told some of Kathy's teachers, hey, Kathy's parents are college graduates. But they told some of other teachers that work with Kathy, oh yeah, Kathy's parents never even graduated from high school. Okay. Then they watched to see how they were graded, see how Kathy got graded. Okay. All right. Our independent variable, okay, is whether or not the teachers were told they were college graduates or not. Okay. And what did that affect? So this would be my independent variable. Okay. What did that affect? How they rated the child's grades or how the grades. This is my dependent variable. Okay. And I hope that didn't really happen, but I could definitely see it happening, that it biased the teachers. They gave better grades to the kid because they thought that, oh yeah, Kathy's parents are college graduates. Just be aware of that as you're working with a student. Okay. Um, so anyway, I just kind of wanted to kind of give you that example. Okay. All right. Let me go back to my other screen here. Sorry for my moment of pause here. Come on. There we are. There we are. Now we're in the right place. Let me move to the next slide here. So I just want to show you another scatter plot, okay, on this particular screen here. Don't worry about copying this down. You could Google scatter plots and you'll find some examples, but this is what your car says about you salary. And I found this on Google this the other day as preparing for this class, okay? So if a person makes 50 grand a year here, okay, if they make $50,000 a year, it looks like the correlation is that they're buying a car that's somewhere around 20, what is that? Some 20 to $30,000, okay, in this kind of range here, okay? What if a person's making over $200,000 a year, they're going to drive a car that costs around $100,000 a year, $100,000. I'm going to tell you right off the bat, this is just not true because I don't know. I mean, I think if you're making $200,000 a year, I don't think, well, I'm sure there are some people out there that spend a whole bunch of money on their car, but that just seems really high. But a chart like this, might be a way of comparing, salary, how much you're making to how much you spend on your car. Okay. So it's another example of a scatter plot. Okay. Again, you don't have to copy it, but you should know that the x-axis here, okay, how much you make, okay, that's my independent variable. It has an influence on the y-axis, the dependent variable, which is how much you spend on a car. Okay. Um, All right. Unless you're like me, and I'm just pretty much dead set. Sorry, but I'm going to buy used cars. That's like what I bought most of the time. Okay, converting large and small. All right, we're moving on to a new concept here. So I'm going to pause my recording. I want you to copy this down, and then we will talk about it, what it all means. All right, we've moved on to chapter 11 in our text, and it's all about conversions, where you're converting things like inches to miles, or millimeters to meters, or grams to kilograms. Um, and and I got to thinking about it when I read the chapter out of the text, and it was so confusing. I thought, well, how am I going to make this? How am I going to teach my students a method that they could just use my system every time and get it right every time? Okay. So I actually designed a kind of a chart system that allows you to figure out how to convert things and get it right every time. And so let me explain my chart here. So if you are converting a larger measurement, like if I say, feet, okay, to inches, okay, I can look at that and I know that feet is the larger unit, right? I just know, just looking at it, that this is the larger, okay, and this is the smaller, okay, unit of measurement. The same could be true of, if I had gallons to cups, okay, of measurements, okay. I know that a gallon is the larger one, and I know that a cup is the smaller. So this is going from large to small. All right. So that's the concept. So if they're asking you to, like in my example, convert 3 yards to how many feet? Okay. So if they're asking you that, I know, okay, yards is bigger than feet. So yards, I'm going from larger to smaller. Here's the rule. The general rule is you're going to multiply something. You're going to do times. And so here's what I do. Here's my chart. I figured, okay, if they ask me to convert yards to feet, and if I know if I'm converting 3 yards, well, first of all, I'll figure out 1 yard. I got to figure out what one of this unit of measurement is compared to the other unit of measurement. 1 yard equals 3 feet. So you notice I'm keeping feet all on the right side and yards mostly on the left side here, okay? All right. So I've got a chart that's got these pieces of information in it at this point. I've got 1 yard equals 3 feet. All right. My rule is when I'm converting a larger unit of measurement to a smaller one, I'm going to multiply something. Okay, that's why I've got the times here. Now, if you look at my chart here, this will help you try to remember, well, how do I remember what to multiply by what? Okay. If I was going to cross multiply, I wouldn't multiply, like, see this 1 yard here, I wouldn't multiply it by feet because I don't know how many feet. That's like X, okay? The 1 and the X aren't what you're multiplying. I'm going to deal with the other two units of measurement in my box here of 4 items here, okay? So I'm going to multiply the 3 times the 3. 3 yards times 3 feet, 3 times 3 gives me 9 feet. And that gives me the answer every single time. So I'm going to repeat. When I'm converting a larger unit of measurement to a smaller, trying to figure out what the smaller unit is, I'm going to multiply something, okay? And if I put it in my equation, 3 yards to how many feet, will I figure out how many 1 yard equals, what am I going to multiply in this box here? Not the feet, not the 1 times anything. 1 times anything doesn't change it. And not the question mark. I don't know what that is. So that's not going to multiply. I'm going to multiply the other 2 items, and that'll give me my answer. Let me show you another example doing the same thing here, okay? And is this the same direction? Larger to small? Yeah, I want to double check and make sure. I didn't want to confuse you, okay? So if they ask you 4 feet equals how many inches? Okay. All right, so I'm thinking out loud here. Feet, they want to know feet to inches. What are these? If I'm just thinking out louder, this is the larger, and I'm converting it to the smaller. I'm just looking at the sentence itself and I'm converting something larger to something smaller. So I'm going to plug it in my chart here. They want to know 4 feet equals how many inches. You see how I wrote this as in inches. I'm going to kind of talk slowly here and let you, if you're trying to copy this down, kind of catch up with me. So the initial question, if I circled it in yellow here, okay, here's the initial question. We wanted to know this, okay? So I'm going to keep everything on the left, feet. So 1 foot, I got to figure out what one is. What is one of these feet? 1 foot equals, I know, is 12 inches, okay? Now I'm going to pause here for a second. And if they were asking you to convert grams to milligrams, which they will in your homework, okay, you can look it up on you can Google it on your phone. You can just type in your phone converting grams to milligrams, and it will tell you how many grams there are or how many milligrams there are in a gram. It'll tell you, and then you just pause and think about that for a minute. Okay, which one's bigger? So if it says 1 gram is 1,000 milligrams, okay, then which one's bigger? The gram must be bigger because it's worth 1,000 of the smaller milligrams, okay? So just know you can use your phone, all right, to look up whatever unit of measurement they're asking to find out what 1 equals. 1 foot's 12 inches. Okay, so look at my thing. I'm going from larger to smaller. And so the teacher said, when I'm doing that larger to smaller, I'm timesing. Okay, that's the rule. I'm going to look at my chart here. I'm going to choose red here just for a second. I'm going to look at these 4 things going on in my chart in a sense here. And I'm going to ask myself, what do I multiply? I wouldn't multiply the 1 in the question mark, no, because that doesn't change anything. And I don't know what the question is. I got to multiply the other two items. 4 times 12 is 48 inches, and that solves the equation. So again, when you're converting a larger unit to a smaller unit, set it up in a chart like this and multiply, and you'll get it right every single time. Okay. All right, we're going to switch now to my next slide, which has to do with converting smaller units to larger ones. And you might want to be sure and write down that in this case, you divide. Again, I'm going to pause to give you a minute to copy down this chart. So the rule is that when you're going from a smaller unit to a larger unit, you're going to divide. That's the rule here. You're going to use some kind of form of division, okay? So it's really important you kind of have that in your notes. So if they ask you, like in my example here, convert 120 seconds to minutes. I'm looking at this yellow question here, okay? And seconds to minutes. I know that this is the smaller unit, okay? I know that. Just it's kind of smaller, okay? And this is the larger one, okay? It's the larger unit of measurement. So I'm going to write on my chart, smaller to larger, 120 seconds to minutes. This is the question they're asking me, okay? And I know that it's smaller to larger. And so I can even add to my chart. That means I'm going to divide something. So I got to figure out, well, what's my unit of 1 here? What 1 minute is how many seconds? It's 60 seconds. Okay. So my larger unit, I find out what one of these is how many of these seconds. Okay. Now, if you're asking, if somebody's asking, hey, teacher, how come you didn't figure out 1 second? Is because you couldn't go 1 second is how many minutes? It's only 1/60th of a minute. So, but 1 minute equals 60 seconds. Okay. All right. The rule says I'm supposed to divide. Let's think about it logically. Here's my initial box here. Okay. I put everything in my chart. Okay. What am I going to divide? Well, I wouldn't be dividing the question mark, and I wouldn't be dividing the 1 because that doesn't change anything. Okay. So what am I left with? I'm left with these 2 boxes here. 120 divided by 60 equals 2 minutes. And that solves the problem. Okay. So again, you're going to have 4 things, you're going to have 4 boxes here, and you're going to be going, okay, which am I dividing here? Which 2? Think about it logically. You're not using the question mark, and you're not using 1 because 1 doesn't change anything. Whether it's multiplied or divided by it, doesn't matter. It doesn't change the number. go with the other two actual numbers. And you're now using the right part of the box, okay? All right, this is another example. You don't have to copy it down because it's the same idea, but I did want to give you an additional sample question. A pill contains 1,257 milligrams, mg, and you'll see this in your homework in your book. It'll say mg. Mg stands for milligrams. This is another reason why I didn't like the book when I wrote to them, is because they assume too many things. They'll just say mg, but of an active ingredient, how many grams are there? So we're converting milligrams, okay, to grams, okay? All right. So if I looked it up on my phone, convert milligrams to grams, okay, or how many grams are, so the initial question is they want to know this. They want to know 1,257 milligrams is how many grams. I look it up on my phone, and my phone tells me that 1 gram equals 1,000 milligrams. Milla means 1,000, okay? Just so you know, like in the Latin, like a millennium is 1,000 years, okay? Um, anyway, so you got a milligram is one of these grams is 1,000 of these, okay? So here's the information I got. I got my 4 boxes now filled in. And I know when I go from small to large, I divide, okay? So what's left? I would go at 1257 divided by 1,000 equals 1.257 grams. So in 1,257 milligrams is the same as 1.257 grams. All right, hope that makes sense. My chart system. And that is it. I can't believe it. We actually finished early tonight. Just to give you the heads up in advance, I wanted to show you something. If I could take a moment here and show you guys all this. I'm going to go to another course here real fast. Come on. All right, this is this class right here, right here. So I just wanted to give you a heads up of what's coming, just to kind of make sure that you are aware of this. Next week, we have our second exam, okay? And I wanted to tell you that this week because sometimes it's a good idea to know what's coming, because sometimes people they kind of rearrange their life and their priorities knowing that something big is coming. So we are currently right now in week 7 of the course, okay? Well past halfway through the course. And I'm kind of testing with what my sound sounds like, depending on how close I get to the microphone. I think it's probably better if I get closer. So I'm looking at week 7, and we're going through these things we just talked about, these chapters. I made a video and recorded it, I think like last quarter, prepping for next week's exam. But you'll see here, next week, exam 2 occurs, okay? So that's another 100-point exam. It's a big part of your grade. You'll also notice this says turn in book homework, chapters 1.6 through 1.10. That occurs next week as well. So next week is 135 points happens next week, okay? So in preparation for that, you know how I sent you a practice sheet that you can practice on and go over the kinds of problems, and then come to my Zoom session and we'll go over the whole thing in class. So you'll have one piece of paper, a couple of pages to it, but one thing on one piece of paper, you'll have everything you need to study for that exam. We'll do that for all of our exams. So I'm just giving you the heads up that next week during the Zoom class here on Tuesday night, real important that you're here. And if for some emergency reason you can't make it, send me an email to remind me to record it. However, I should also mention to you this prep video that I put in this week, just a few days in advance, is my recording from last quarter, prepping for this same exam. So that's also there now already. So anyway, so next week we're gonna Zoom session is gonna be all about prepping for you for the exam. You can take the exam anytime you want next week. Plus, be sure and turn in all of your book homework for chapter 6 through 10, essentially, okay? And then I do want to remind you to keep doing your WAMAP homework. Stay up. So what chapters are you doing in WAMAP? The same exact chapters that you, like this reminder, you're going to do 1.10 and 1.11 in WAMAP, same exact chapters, because the content is the same material, okay? All right, I'm going to switch and put myself on camera again and say goodbye to my recording.